Hello, everyone, and thank you for taking the time to watch our webinar series. And we'll start with our first webinar as an intro for the other webinars we will be presenting. My name is Zvika Wiseman, and I'm the Director of the Aerospace and Defense Digital Manufacturing Solutions in Siemens Digital Industries Software. So let's start. When we are looking at the aerospace and defense industry, which is a major industry to which we offer our solutions, we see the key trends that are impacting this industry. And obviously, we are talking about a complexity which is increased over time, a level of complexity that makes maybe other solutions, all kind of desktop solutions, which were good solutions at the time, might not be sufficient for the level of complexity that the industry is currently coping with. And then we are talking about sustainability. So nowadays, aerospace and defense manufacturers are not only looking to manufacture their product in the right quality level, but they're actually looking also, while doing so, to minimize the footprint on the environment, on Earth, and to make sure that they are using manufacturing processes which are greener as possible. And then talking about the supply chain, as we know, the supply chain today is very, very global. A lot of quality-related checks that a company needs to do in order to validate the deliveries of its suppliers, which makes it also complex to manufacture on time and on quality. And then the last point is, of course, the workforce from different aspects. Some people would say that in this specific industry has an aging workforce. And of course, the challenge here is to transfer the knowledge to the next generation to make sure that the knowledge of these experienced individuals are not, that the knowledge is not only in their mind or on the desktop, but that the knowledge is actually a propriety of the organization and can be shared with the relevant people. And then you want also to make sure that you can attract the young generation to work in this industry. And then last but sure not least is to make sure that you are providing your workforce the right environment to do their task, and that obviously, as we're talking with manufacturing operation, that you are making sure that your workforce will stay healthy. So when we are talking about our solution for the aerospace and defense industry, we are actually starting from the typical challenge of the industry. And as we see it, the typical challenge is to be able to predict the manufacturing processes. In order to resolve the problems that are typical for a manufacturing environment, the first thing you need to do is actually to create an environment with which you can predict all these issues and challenges. And we are talking here on a virtual environment, a virtual production environment. We are calling it the production digital twin. And the essence of this production digital twin is the ability to create a virtual model of the production, which is as close as can be to the real production, which will take place later. And in this virtual environment, once it is close in its behavior to the real production, you can do all kinds of validations, check all kinds of what-if scenarios, do some optimizations, and make sure that eventually that the process that you send to the shop floor can be executed right the first time. Of course, that this requires some investment in setting up this virtual environment, this production digital twin, but we believe that there is a great return on this investment. So we are basically talking on the tools, which we call the intelligent manufacturing solution, which will enable to build the needed products in the needed time frame, in the needed quality. And actually, here we are talking about model-based manufacturing. So, you know that in the industry, we are talking a lot about a model-based enterprise, and part of a model-based enterprise is the part of manufacturing, which is the model-based manufacturing, which actually means that we are leveraging for the manufacturing engineering, for the manufacturing execution, all the assets that are created by design engineers in order to create the plans and to execute the manufacturing. And this model, which is created in the first phases of the program, is actually serving the later phases of the program. And once we are having this model and we are leveraging it to do the manufacturing planning to create the manufacturing related assets, then we are having this production digital twin, which is the virtual version of production. And later on, we are having the physical production, the real production. And obviously, we want to make sure that they are as close as can be. So if there are changes that will happen in the real production, we want to reflect it on the virtual model to make sure that even after start of production, you can continue to use your virtual production model in order to do all these changes, improvements, without actually impacting the real production that takes place in the shop floor. And once you are doing all this, obviously you can optimize your manufacturing processes in order to produce the optimized products. And then collecting this data in the shop floor and feeding back the information to the previous steps, we are actually enabling a continuous improvement, or the way it is called in the Japanese, a Kaizen process, in which you can continuously improve your production operation and have an excellent manufacturing method and operation. We are going to issue a series of webinars in which we will focus mostly on assembly, and we will actually show the solution that we offer in order to create a holistic model of an assembly line, a manufacturing line, in which you can do all kinds of capacity planning, check different assembly alternatives, and check the size of the needed buffers, identify the bottlenecks, all of this of course, in a virtual model. And then, as you can see on some of the images, plan the process. You can see in the top middle how we actually take this product that is coming from the design engineering and create a manufacturing view of this product. This is the process that we call the engineering bill of material evolvement into a manufacturing bill of material. This is why you see the two airplanes. And then once you created this manufacturing bill of material, you want to do your bill of process to model your manufacturing, your quality inspection bill of process. And then once you created your bill of process, you want to validate it. You want to make sure that once you will send it to the shop floor, it can be executed. And therefore, you are using all kinds of simulation tools to do a simulation of manual assembly processes, to do simulation of automated assembly processes, machines, industrial robots. We are seeing new concepts that are penetrating to the industry, like AGVs that you see on the top left image. And obviously, we want also to enable aerospace and defense companies to plan this advanced production and setting up what we sometimes call the aerospace and defense factory of the future. So what would be the benefits that will be realized by using the Siemens solution? And first, we are talking about a faster ramp-up. A faster ramp-up is obtained by the fact that all stakeholders are connected very well together in what we call the digital thread, and such that they do not need to chase after data. The data is fully available for them for processing. We are talking about the reduction of cost both in the engineering environment and also in the manufacturing environment, because of the digitalization of the manufacturing process, which removes a lot of barriers and removes a lot of duplications and mistakes along the process. And ultimately, obviously, when producing the product, we are talking about the ability to deliver it right the first time, which I would say we all agree that this is a common goal for all aerospace and defense manufacturers. So we are actually helping companies to establish this digital thread that connects product designers, manufacturing engineers, and manufacturing execution people, the people that are dealing with the product support or maintenance, and make sure that all the data is available back and forth to support all kinds of improvement cycles, change cycles. From our experience, a lot of companies, aerospace companies during the years, build their own mechanisms to connect the data flow from engineering down to the shop floor. But I can tell you that still a lot of companies are struggling with the look back, what we call in Siemens the closed loop manufacturing, with making sure that feedback and information from the shop floor is flowing all the way to the manufacturing engineers, design engineers, and to make sure that they are aware of the impact of the processes and the product that they plan and can improve it for next time. In Siemens, we focus in the aerospace and defense solution, in delivering solutions for the aerospace and defense industry. We have customers from different zones all over the world, different segments of the aerospace and defense industry. We are having airframers, we are having OEMs, suppliers, defense customers, space customers. You can see here some of the logos. I'm sure that you recognize most of them, and all of them would use solutions from Siemens digital industry software in order to improve their operation. With that, basically, I'm signing off the first webinar, which is a very generic introduction, and looking forward to the next webinars, which we are going to publish, in which we'll go more into the details of our different planning and simulation tools. Thank you for joining. Thank you for watching this webinar, and see you in the next one.